Okay, greetings one and all, and welcome to this math lesson. In this math lesson, we'll be considering a Bgcse Math Paper 2 2023 past paper. And so let's begin. So here we have Paper 2 Mathematics. This is a Bgcse past paper, and we're going to be diving into this paper, answering the questions and explaining how to get these solutions. Okay, let's begin. Okay, the first question says a college sent out 3,150 invitations to their summer graduation. 5,000 invitations were sent out last year. Find the percentage decrease in invitations sent. So if we want to find the percentage decrease, the first thing we need to do is we need to subtract 3,150 and 5,000, right? We have to find the difference of those two numbers. All right, so let's do that. So the percentage difference, the formula that we could use is the difference in invitations. That's, we have to subtract these two numbers. Then after we subtract these two numbers, we're gonna divide it by the original invitation, which is 5,000. We're gonna multiply it by 100 over 1 because we're trying to find a percentage. Okay, so let's find the difference, 5,000 minus 3,150. So we have to subtract those two, right? We put it over 5,000, that's the original amount because that's what they sent out last year. Multiply that by 100 over 1. And so when we subtract 5,000 and 3,150, we get 1,850 divided by 5,000 multiplied by 100 over 1. We multiply the numerators. So 1,850 multiplied by 100. That gives us 185,000. And then we multiply 5,000 by 1, and that gives us 5,000. Here, all we have to do is divide, and when we divide these two numbers, we get 37. So that means that the percentage decrease is 37. So there was a 37% decrease in invitations sent compared to last year. Okay, let's continue. The next question says, represent each sentence as an algebraic inequality. So here, this one says x is at most 69, which means that the highest x can be is 69. So we represent it as x is less than or equal to 69. We say less than or equal to because it could be 69. The highest it could be is 69. So it's basically 69 and lower, right? So that's why it says x is less than or equal to 69. We put the equal to sign, which is a line underneath. So this is less than, and we put equal to by the bar underneath to indicate that x could be 69, right? So x is 69, or x could be lower than 69. Okay, next question says y is at least 100. Y is at least 100. When we say y is at least 100, we mean that y could be 100, right? Or greater. So it's at least 100. So it's 100 or greater. All right, and so that's why we have y is greater than or equal to 100, because it could be equal to 100 or it could be greater than 100. So y is greater than or equal to 100. That's the symbol that we use, and this is how we represent it. Next, we have that the minimum value of z is 25, which means that the smallest z can be is 25. So it could be 25 or higher than 25. So it could be 25 or greater. So that means we have z is greater than or equal to, the line underneath means equal to. So z is greater than or equal to 25. So it could be 25 or higher, okay? Okay, so draw a line showing the inequality n is greater than or equal to 2. So let's draw the number line. We have negative numbers, 0, and positive numbers. Now we have to look for 2. Wherever we see 2, we're going to put a circle. Now we shade the circle because it says n is greater than or equal to. Because of that line underneath, we shade the circle. If the line was not underneath, we're just going to have an empty circle that is not shaded. Now it says greater than 2. So what are the numbers that are greater than 2? 3, 4, 5, 6, 7, 8, 9, 10, and continuing on. These numbers are greater than 2, so we're going to put an arrow to the right. Let's move on to the next question. Here we have question number 3, which says there are several t-shirts on a rack in a store. 2/3 or 2 over 3 are white, 1/8 are pink. All the remaining t-shirts are blue. Find the fraction of t-shirts that are blue. So we have 2/3 of the shirts that are white, 1/8 that are pink, and then we have a remaining t-shirts that are blue, right? And we're trying to figure out, or our goal is to figure out, well, how many, well, what fraction of these t-shirts are actually blue? So the first thing we're gonna do is we're gonna add these two fractions. So the fraction of white and pink. So let's add them. And when we add them, we have 2 over 3 plus 1 over 8. They have different denominators, so we have to try to make the denominators the same by finding the lowest common multiple of 3 and 8, which is 24. We multiply 3 times 8, and we multiply 2 times 8, because whatever you do to the body, we must do to the top. Then we multiply 8 by 3, and we multiply 1 by 3, because we're trying to get 24 at the bottom. So 3 times 8 is 24, 2 times 8 is 16, 8 times 3 is 24, and 1 times 3 is 3. So now we have the denominators are the same, so we have 16 over 24 plus 3 over 24. The denominators are the same, so we can add these fractions normally. So we say 16 plus 3. We only add the numerators. We do not add the denominators. The denominator just stays the same. So 16 plus 3 is 19 over 24. So that means that if we were to combine the white t-shirts, the fraction of white t-shirts and the fraction of pink t-shirts, we get 19 over 24. Now to find the fraction of the blue, what we need to do is we need to subtract 1 and 19 over 24. We could write 1 as 24 over 24. So 24 is over 24 because that's a whole, right? So 24 over 24 minus 19 over 24, that's going to give us the amount of blue shirts that are left, right? So when we subtract 24 minus 19, we get 5. And notice that for the denominators, they just stay the same, right? So what we did was we wrote 1 as a fraction, which is 24 over 24, because 24 over 24 is a whole. And we subtract 19 over 24 because that is the pink and the white, but we want the remaining. So the remaining would be 5 over 24. And we got the 5 because 24 minus 19 is 5. And for the bottom, we just keep it the same. Okay, so the answer here is 5 over 24. That's the fraction of blue shirts that are left. Okay. Okay, let's move on to that's the fraction. So 5 over 24 is the fraction of t-shirts that are blue. And we know the fractions of t-shirts that are blue are the remaining, right? Because there's only 3 that were mentioned, 3 colors that were mentioned. Okay, there are 20 blue shirts on the rack. Find the total number of t-shirts on that rack. So they give us a hint. They tell us that 20 blue shirts, 20, they tell us that we have 20 blue shirts, all right? And so they want us to figure out what is the total number of all the shirts that are on the rack. Well, we don't know what that is, so we're gonna say let T equals the total number of t-shirts on the rack. So T represents the total. We don't know what that is, but we just use a letter to represent that number. Now, if T is the total, that means that if we multiply our fraction of blue shirts by T, we're going to get 20 because there are 20 blue shirts. So we say 5 over 20 multiplied by T, the total, is going to be equal to 20. Now, if we knew what this value was, then it was going to immediately give us 20. But since we don't know what this value is, we represent the variable, represented by using a variable, which is T. And we know, based on the question, they tell us that, hey, it's going to be 20. So even though we don't know what this variable is, we know that when we multiply the fraction of our blue shirts by that number, we will get 20. Because 5 over 24 is the fraction of blue shirts. If we multiply that by the total, it's going to give us 20 because there are 20 blue shirts on the rack. Okay, we're going to put 20 over 1, right? And then we're going to cross multiply. So we have 1 times 5t and 24 times 20. We say 1 times 5t, which is 5t, and 24 times 20, well, we put that on the right-hand side. And 24 times 20 is 480. So we have 5t equals to 480. We're going to divide both sides by 5. And if we divide both sides by 5, all we have to do now is cancel these two 5s. So this one cancel with that one. And so we are left with t is equal to 480 divided by 5, which means that t is equal to 96. So that means that the total number of t-shirts on the rack is 96. Okay, let's move on to the next question. It says a fisherman has 10 groupers for sale. The mean weight of the 10 groupers is 14 kilograms. He sells 2 groupers that weigh a total of 32 kilograms. Find the mean weight of the remaining groupers. Now, mean is an average, right? So if you're doing the mean, we're basically going to add up all of the groupers and divide it by the amount of groupers that you have. Now, what they did is they told us that the mean weight of the 10 groupers is 14 kilograms. And so we know that the mean weight, right, of the groupers is 14 kilograms. Now, I have this equation right here, and this equation is going to be useful in helping us because the equation says the mean weight over 1 is equal to x over 10. And so why did I put it like this? Well, we know that the mean weight is going to be equal to the sum of all of the 10 groupers divided by the amount of groupers that we have, which is 10. So the mean weight, right? The mean weight is going to be equal to the sum of all of the weights, which is x, because we don't know the sum of all the weights. So that's why we put x, divided by the amount of groupers that we have, which is 10. And I put it over 1 because I'm about to cross multiply. And so what is the mean weight? Well, they told us what the mean weight was. They told us that the mean weight is 14. So we have 14 over 1 equals to the total number of the sum of all of the weights, which is x divided by 10. Now, in order for us to find the sum of all the weights, we have to cross multiply. So we have 1 times x, which is x, and 10 times 14, which is 140. So 1 times x is x, and 14 times 10 is 140. So that means that x is equal to 140. What is that telling us? That is telling us that if we add up the sum of all of the weights, right, of all of the weights of the groupers, we're going to get 140, all right? And the mean weight is 14, and that makes sense because the mean weight is going to be equal to the sum of all of the weights divided by 10. And if we take 140 and divide it by 10, we get 14. So it makes sense that the sum of all of the weights of the 10 groupers is 140. Now they tell us that he sells two of the groupers that weigh a total of 32 kilograms. So we know that the weight of the 10 groupers, which we just found, is 140 kilograms. Now, if we want to find the weight of the 8 groupers, we know that 2 of them combined makes for a total of 32 kilograms. And so we got to subtract 140 kilograms and 32 kilograms. And when we subtract them, we get 108 kilograms. And so that is the weight of the 8 groupers. It says that find the weight of the remaining groupers. Well, we know that the weight of the 8 groupers is 108 kilograms. We just figured that out because we subtracted the 32 kilograms, which is the weight of the 2 groupers which he sold. And then all we got to do now is divide this amount by 8 because if you're trying to find the mean weight of the 8 groupers, we're going to take the sum of all of the 8 groupers, which is 108 kilograms, and divide it by the amount of groupers that we have, which is 8. And so 108 divided by 8 is going to be 13.5 kilograms. So the mean weight of the 8 remaining groupers is going to be 13.5 kilograms. Okay, let's move on to the next question. This is number 4. We move on to number 5. It says that the interior angle of a regular polygon is 162 degrees. Calculate the size of each exterior angle. So let's look at this image. The exterior angle is going to be the angles that are on the outside, right? The angles that are on the outside. That's what I mean by exterior angle. What are the interior angles? Well, the interior angles are going to be the ones that are on the inside, all right? The ones that are inside of the polygon, and the exterior angles are going to be the ones that are on the outside of the polygon. Now, they told us that the interior angle of this polygon is 162 degrees, which means that, just to give you a visual, now this is not the exact image for this particular polygon, but it's just to give you an idea of what we mean when we say interior versus exterior. And so if we notice that we have this one is the interior angle, and they say that this is 162 degrees. Now the exterior angle is going to be this one. And if you notice that these are on a straight line. All right, these are on a straight line. So if this is 162 degrees, right, which is the interior angle, and this is the exterior angle, and they're on a straight line at a common point, we know that angles on a straight line at a common point add up to 180 degrees. So if we're trying to find the exterior angle right? The one on the outside, right? Given the interior angle, we have to subtract the interior angle from 180 because angles on a straight line add up to 180 degrees. And so what that means is that we're going to have exterior angle equals to 180 degrees minus 162 degrees, and that gives us 18 degrees. And so in general, if we're trying to find the exterior angle and we have the interior angle, all we have to do is subtract 180 minus the interior angle, which is 162. Now this is, again, this is not an exact replica of this particular polygon, but this is just a diagram that I use just to help you understand the concept of interior and exterior angle and the idea or the thought process of why or how we are subtracting or why we're subtracting using 180 degrees, because it's going to be on this, these two angles are going to be on a straight line, and we know angles on a straight line at a common point add up to 180 degrees, and so we just have to subtract the 162 from the 180 to get our 18, and that's going to be our exterior angle. Okay, let's move on to the next question. This one says the interior angle of a regular polygon is 162 degrees. It says calculate the number of sides of the polygon. So here they gave us the interior angle, and now they want us to find the number of sides. And so here we have a useful formula that we can use. It says that the interior angle is equal to 180 degrees, open bracket, n minus 2, close bracket, all over n, right? Where n is the number of sides. And so we have to find what is the number of sides. We know that the interior angle is 162 degrees, so we're going to substitute the 162 for the interior angle. Now I put it over 1 because I'm preparing to cross multiply. And so we cross multiply, so we say that 1 times 180 times n minus 2 is itself 180 times n minus 2 because 1 times anything is itself. And we say n times 162 is going to be 162 times n. And so now I'm just going to distribute. We say 180 times n and 180 times 2. Well, 180 times n is going to be 180n, and 180 times 2 is going to be 360. And so what does that mean? That means that we can send over the 180n because we have 162n and 180n. And so they are like terms. We're going to send this over. You do not need to put this brackets here. I should not have this brackets here. Okay, so do not put this brackets here. All right, let's move this. This bracket should not be on that side. It should just be, you should remove the brackets after you distribute. Okay, so now what we have 180n. We send that over. It was positive 180n, so now this is going to be negative 180n. So we have 162n minus 180n equals to negative 360. Now we're going to subtract 162n minus 180n. That's going to be equal to negative 18n equals to negative 360. We divide both sides by negative 18. And so we can cancel out this negative 18 and that negative 18. So we get that n is equal to negative 360 divided by negative 18. And when we divide them, we get 20. So negative 360 divided by negative 18 is positive 20, which means that the number of sides is going to be 20. So if we have an interior angle of a regular polygon that is 162 degrees, that means that that polygon has 20 sides. Okay, let's move on to the next question. So number of sides of this polygon is 20. The next question says two vectors A and B are shown on the grid below. Write as column vectors A and B. So we have these vectors here on this grid, and they want us to write these vectors, vector A and vector B, they want us to write them as column vectors. If we notice here, we moved, so the vector A is going in this direction, right? But if we, if we show the X movement and the Y movement, it will be like this. So on the X axis, we moved 1, 2, 3, 4, and 5, right? So we move 5 times to the right. And we also moved on the Y axis, 1, 2, 3 times down. So we move 5 times to the right and 3 times down. And so that's the movement of this vector. So if we were to represent this as a column vector, it would be A is equal to open bracket 5 and negative 3. The reason why we have positive 5 is because we moved 5 times to the right. 1, 2, 3, 4, 5. And the reason why we have negative 3 is because we moved 3 times down. 1, 2, 3. So we write the X movement on the top and we write the Y movement at the bottom. Okay, let's move on to the next one. Here we have vector B and it's going in this direction, right? Vector B is going in this direction. And so what does that mean? Well, that means that we moved 1, 2, 3, 4, 5 spaces down, right? 5 times down. And then we moved 1, 2 times to the left. So because we moved 2 times to the left, we have -2. So to the left, it's going to be negative. To the right, it's going to be positive. And because we move 5 times down, 1, 2, 3, 4, 5, it's going to be -5. So as a column vector, A is 5 and -3, and B is -2 and -5. Okay, the next question says, write as column vectors B, A plus B. So now that we already know that now that we already got the column vectors, now we just need to add them. So A plus B is going to be equal to the column vector for A plus the column vector for B. We're going to add them, add corresponding entries. So we have 5 plus -2, and 5 plus -2 is +3. And we have -3 plus -5, and that's going to give us -8. And so the answer, the sum of these two vectors, A plus B, is going to be 3, -8. Okay, let's move on to the next question. It says, write as column vectors 2A. Now 2 is a scalar, so we're going to multiply a scalar by a vector. And so when we do that, in order to multiply the scalar 2 by the vector A, we're going to say 2A equals 2, open bracket 5, -3. And we're going to take the 2, right? We're going to take the 2 and we're going to multiply it by each term. So we're going to take the 2 and multiply it by the 5. And we're going to take the 2 and multiply it by the -3. And so we have 2 times 5, which is going to be 10. And then 2 times -3, which is going to be -6. Okay, let's move on to the next question. Here we have question number 7, which says Samantha leaves home at 7:55 a.m. and drives 75 kilometers to work at an average speed of 60 kilometers per hour. It takes 15 minutes for her to walk from the parking lot at her work to her office. Determine her arrival time at the office. So the first thing we need to figure out is we need to figure out the time. And what's very useful is this speed, distance, time triangle. And it tells us that if we're trying to figure out the time, we have to do distance over speed. And so time is distance over speed. What is the distance covered? The distance covered is 75 kilometers. And the time is the distance covered is 75 kilometers. And the speed is 60 kilometers per hour, right? It says she drives to work at 75 kilometers. Sorry, she drives 75 kilometers. That's the distance. And the average speed is 60 kilometers per hour. So distance is 75 kilometers and speed is 60 kilometers per hour. Okay, now we're going to divide them. And if we divide 75 and 60, we get 1.25 hour, which is basically 1 hour and 15 minutes. How do we get that? Well, we know that 0.25 multiplied by 60 is going to be 15, and that's 15 minutes, because when we multiply 0.25 by 60, remember that, or recall that 1 hour is 60 minutes, right? So 1 hour is 60 minutes. So if we take 0.25 and we multiply it by 60, we get 15, which is 15 minutes. So that means that this point 0.25 is actually 15 minutes. So we have 1 hour because of the 1 here, and 15 minutes because of the 0.25 that we converted from hours to minutes. Okay, so we have that the time taken is 1 hour and 15 minutes. How do we interpret that? What does that mean? Well, that means that if she left home at 7:55, that means it took her 1 hour and 15 minutes to get to the parking lot at her office. All right. So it took her understanding the distance and understanding the speed that she's Understanding the distance that she has to cover and understanding the speed that she's traveling with, it took her 1 hour and 15 minutes to get from her home to her work parking lot. All right. Now, there's another thing now. It takes her 15 minutes to walk from the parking lot at work to her office. So she arrived at work in an hour and 15 minutes, leaving home at 7:55. But she has to walk from the parking lot to the office, so that takes up some time. So we have to add that, right? So we have hours and minutes. Remember, it's 7 hours and 55 minutes. So we have 7 hours and 55 minutes. So we have 5 plus 5, which is going to be 10. So we have 5 plus 5, which is 10. We put the 1 up. That's going to be 5 plus 1 plus 1, which is going to be 70. So we have 8 plus 1, which is going to be, 7 plus 1, which is going to be 8. So it's going to be 870. So how do we interpret this? Well, 870, that's the time. That's the time that she arrived at the parking lot. Now she has to take 15 minutes to walk from the parking lot to her office. So this time right there, what we just calculated was we did 7 hours and 55 minutes. That's the time that she left home. And we add that to 1 hour and 55 minutes to determine what time she arrived at the parking lot. And so we got 870. That's the time that she arrived at the parking lot. Now we need to add this 870, right, to 15 minutes because it takes her 15 minutes to get to the office. And so it's going to be 870 plus 15 minutes. And when we add them, it's going to be 0 plus 5, which is going to be 5, 7 plus 1, which is going to be 8, and 8 plus 0, which is going to be 8. So the time that she arrived at the office is going to be 8:85. Now, we don't say 8:85 in everyday language. We recognize that every hour is 60 minutes. So we're going to minus 85 from 60. And so 8 hours and 85 minutes is actually 8 hours, 60 minutes, and 25 minutes. How do we do that? Well, we subtract 85 and 60 to get 25. And so we have 8 hours and 85 minutes is actually 8 hours, 60 minutes, and 25 minutes. We know that an hour is 60 minutes, so we convert 60 minutes to an hour. So you have 8 hours, 1 hour, and 25 minutes. If we add 8 hours and 1 hour, we get 9 hours and 25 minutes. And so that means that she arrived at her office at 9:25 a.m. So she left home at 7:55 a.m. It took her 1 hour and 15 minutes, like we calculated. It took her 1 hour and 15 minutes. It took her 1 hour and 15 minutes to get from her home, right, to the office, to the parking lot rather, of her work. And so she arrived at 8:70, and then she have to walk another 15 minutes. So it's going to be 8:70 plus 15 minutes. And so that gives us 8:85. That's the time that she arrived at the office. And if we convert this into regular time, it's going to be 9 hours and 25 minutes, which is 9:25 a.m. That's the time that she arrived at the office. Okay, let's move on to the next question. This one says factorize 16ab to the third power c minus 8ab plus 32a squared bc squared. And so that's what we have. What we're going to do is we're going to take out the common factor. So something that is common in all of the terms. And if we notice, 8ab is common in all of the terms. So we have 8ab. So 8 times 2 is going to be 16, right? So that's how we get the 16 now. And then a is already here, right? And then we say b times b squared, that's going to be b to the third power. And then c, we put c here because c is there. So basically the idea is that if we have our common factor is 8ab, and we're going to take that common factor and try to figure out what we need to multiply it by to get this term. All right, so if we have 8ab and we multiply it by 2b squared c, we're going to get 16ab to the third c, right? And we just proved that because 8 times 2 is 16. A is just going to be, we're just going to insert it there because we don't have another a to multiply with, so it's just a. And then b times b squared is going to be b to the third. And then we put c here because there's not another c to multiply it. So we put c here because c is not a common factor, so we just leave it here. And if we multiply 8ab times 2b squared c, it's going to be 16ab to the third c. Okay? So that's that one. So we have this common factor, and we have to multiply it by this term to get 16ab to the third c. So that part is done. Now let's move on to the next part. We have 8ab. All we need to do is multiply by 1 to get 8ab back. So that one is easy. We don't have to do anything for that one. And then for this one, we have 32a squared b c squared. And so how are we going to get that? Well, we know that 8 times 4 is 32, all right? And then we know a times a is a squared, right? And we have to insert the b here. And we have c squared. And so if we take 8ab and we multiply by 4ac squared, we get 32a squared bc squared. And so that means that we know our factorization is correct, because if we take the common factor and multiply it by these terms, we get our expression back again. Okay, let's move on to the next question. Here we have 1.1a plus 3.3 minus 5 open bracket 3 minus 0.2a. So here, the first thing we're going to do is we're going to distribute. We're going to take 5 and multiply it by the 3, which is 15. And we're going to take 5 and multiply it by 0.2a. It's important to note that we are considering the negative. So it's going to be negative 5 multiplied by 3. So it's negative 15. So let's do that. Negative 5 times 3 is going to be negative 15. And negative 5 multiplied by 0.2a is going to be positive 1, because negative times a negative is a positive. So this is positive 1a. And we just bring down everything on this side. So we have 1.1a plus 3.3. Now we're going to combine like terms. So we're going to group like terms. And so we have this 1.1a along with this 1a, we bring them together, right? So 1.1a and 1a, we bring them together. And the constants, the numbers 3.3 and 15, we bring them together here. Now we have 1.1a plus 1a, and we have 3.3 minus 15. So we're going to combine the like terms. So 1.1a plus 1a, that's going to give us 2.1a. And here for 3.3 minus 15, well, 3.3 minus 15 is going to be 11.7. And so here we cannot simplify anymore because these two are not like terms. So we just leave it like that. Our answer is just 2.1a minus 11.7. Okay, let's move on to the next question. Here we have 3x divided by y squared, all raised to the power of 3. What we're going to do here is we're going to take this 3 and we're going to we're going to count it for the 3x. We're going to take this 3 and we're going to count it for the y squared, right? And so what does that mean? That means that we're going to take this 3 and we're going to put it for the numerator. We're going to take this 3 and we're going to put it for the denominator. So we have 3x raised to the power of 3 and y squared raised to the power of 3. Now we're going to take this 3 and we're going to put it for each term, each one of these terms. So 3 raised to the power of 3, x raised to the power of 3. All right, so that's going to be 3 raised to the power of 3 and x to the power of 3. Now here we have y squared. So we have a power on the inside and a power on the outside. When it's like that, you can multiply them, right? So it's going to be y raised to the power of 2 times 3. And so we have 3 cubed, which is 9. I'm sorry, 3 cubed is not 9. 3 times 3 is 9. But 3 cubed, that's 3 times 3 times 3. That's going to be 27. And then we just put x cubed there. And then 2 times 3 is 6. So we have y raised to the power of 6. So we have 27 x cubed all over y6. There's nothing more that we can simplify here. So we leave it as is. Okay, let's move on to the next question. Here it says a floor is covered with 16-inch square tiles. There are 17 and a half tiles. There are 17 and a half tiles along. Sorry, there are 17 and a half tiles along the width and 19 tiles along the length. Using 1 inch equals to 2.54 centimeters, find in centimeters the width of the floor. So we have a floor, right? So we imagine a floor, right? So this is our example of our floor. Now the floor has 17 and a half tiles along the width. So we have 1 tile, 2 tile, 3 tiles, 4 tiles, 5 tiles, 6 tiles. You get it. All the way up to 17 and a half tiles along the width, right? Now, each one of these tiles is 16-inch square tiles. So they measure 16-inch, right? These are 16-inch square tiles. So each one of these measures 16-inch, right? 16 inches. So each one of these are 16-inch square tiles. Remember, we have 17.5. I only drew a certain amount, but imagine with me that we have 17.5 across the width, all right? Okay, so they want us to determine the width of the floor. Well, the width of the floor is going to be 16 times 1, 2, 3, 4, 5, 6, all the way up to 17.5, right? So the width of the floor is going to be 16 inches times 17.5, right? Because each one of them covers 16 inches, right? And you have 17.5 of them, so you multiply it by 17.5. 17.5 is 17.5, so if you multiply 16 times 17.5, we get 280 inches. So the width of the floor is 280 inches, but they don't want it in inches. They want it in centimeters. And so that means that we need to take 280 inches and convert it into centimeters. How do we do that? We know that 1 inch is equal to 2.54 centimeters. So you're going to multiply 280 by 2.54. And so we get 711.2 centimeters. So the width of this floor in centimeters is 711.2 centimeters. Okay, let's move on to the next part of the question. It says we want to figure out the length of the floor. So imagine our floor again. We have 1 tile, 2 tiles, 3 tiles, 4 tiles, 5 tiles, 6 tiles. We actually have 19 tiles along the length, right? I only drew a certain amount, but imagine we have 19 tiles along the length. And notice that it says that each of these tiles is 16-inch square tiles, so it's going to be 16, 16, 16, 16, 16, 16, all the way up to 19 tiles. And so if we want to figure out the length of the floor, we have to take 16 inches and multiply it by 19. And so 16 times 19 is going to be 304 inches. But they don't want it in inches. They want the length in centimeters. So we're going to convert it to centimeters by multiplying by 2.54 because they say it right here. 1 inch is equal to 2.54. So if we have 304 inches, in order to convert that into centimeters, we have to multiply by 2.54. And so we get 772.16 centimeters. That's going to be the length of the floor. Now, let's move on to the next part of the question. It says, find the area of the floor in square inches. Now, what is the formula for area? Well, area is going to be, it says find the area of the floor in square meters. So area of the floor is going to be equal to length times width, right? What is the length? The length is 772.16 centimeters. That's what we found from the previous question. But they don't want it in centimeters. They want our answer in square meters. So you have to take centimeters and convert it into meters. How do we do that? We have to divide by 100. And so 772.16 divided by 100 is definitely 7.7216 meters. So the length is going to be 7.7216 meters. Now we have the width. The width is 711.2 centimeters, but they don't want it in centimeters. They want it in meters. So you're going to divide it by 100 to get it in meters. So it's going to be 7.112 meters. So now we have the length in meters and we have the width in meters. Now, in order to find the area, we just need to multiply them. So the area of the floor is going to be 7.7216 meters times 7.112 meters. When we multiply them, we get 54.9160192 meters squared. But they didn't ask for a certain degree of accuracy. So what I'm going to do, I'm just going to put it to 2 decimal places, just so we wouldn't have this long thing. And so we're going to round to 2 decimal places. And so we get 54.92 because this number here is 6. And since it's bigger than 5, we're going to add 1 to the 1 already. So it's going to be 5.5. It's going to be 54.92 because 1 plus 1 is 2. So we get 54.92 meters squared. That's the area of the floor, correct to 2 decimal places. Okay, let's move on to the next question. Here we have a circle theorem question. And it says that the circle ABC has center at O. So circle ABC has a center at O. So this is the origin. DE is a tangent. So here DE is the tangent, right? The tangent line is going to be that line that touches the circle at one point, right? And we have BAC is 37 degrees. That's this one, BAC, right? That's this one, that's 37 degrees. And angle ADC, angle ADC, angle ADC, right? Angle ADC is going to be 65 degrees, all right? And so they're saying, using this information, determine the angle ABC. Now for this one, notice that they want us to figure out angle, they want us to figure out angle ABB, angle ABC. Now when they say angle ABC, they actually really referring to the one in the middle, right? Angle B. But they give us these letters to know which triangle they're talking about. So ABC, well, ABC, so this is going to be A, that's where A is, A to B, right? Right? And then B to C, right? So they're actually referring to this triangle. So it's going to be, so angle ABC, so they're referring to this triangle. And they actually want us to figure out this angle right there, the one in the middle, angle B, right? So what is the measurement of this angle is the question. But we have a useful theorem, and the theorem tells us that the angle in a semicircle is 90 degrees. So if you notice, right, this right here, right, this line is the diameter. It cuts the circle into two halves. So this part is a semicircle and this part is also a semicircle. So the angle in the semicircle, right, is 90 degrees. So this angle right here is 90 degrees, right? And this is exactly what we have here. This right here is going to be 90 degrees because angles in a semicircle is 90 degrees, all right? So just put 90 degrees for that one. Okay, let's move on to the next one, B. We have, we want to find out angle BCE, angle BCE. So BC, so BC and E. Okay, this one right now, BC and E. So this is what we're looking at. We want angle BCE. Now notice carefully that they actually want the angle in the middle. So the angle in the middle is going to be C. So they want to figure out the measurement of this angle right there. This particular angle right there. Let me show you this one, right? They want the measurement of that angle, right? Angle BCE, right? So use erase all link. So they want us to figure out what is the measurement of this angle right there. Let me use red. So they want us to figure out the measurement of this angle right there, right? What is the measurement of this angle, right? Okay, so in order to figure out the measurement of that angle, what we need to do is we need to recall, or if you don't know it already, I'm going to introduce it to you. This theorem, it's called the alternate segment theorem. The theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So what we have here is, if we were to explain it, we have here a tangent line, right? This is the tangent. The tangent line is going to be the line that touches the circle at one point. And so they're saying the angle between the tangent and the chord. The chord, this is the chord, right? This is the chord of the circle, right? It's the chord of the circle. It's the chord because it stretches from end to end of the circle, right? It's a line segment that stretches across end to end of the circumference of the circle. So it touches one end of the circumference and touches the other end of the circumference. That's the chord. So they're saying the angle formed, this angle right there, theta, the same angle right there, that is formed between the tangent line, this one, and the chord, right? The tangent line and the chord, the same angle right there, this one right there, theta. That same angle is going to be equal, to the angle subtended by the same chord in the alternate segment. So if we look carefully, what is that chord? This is the chord, right? And what is the angle subtended by the same chord? Well, if we look at this chord, right, and we look at this angle theta, this is the angle that is subtended by the chord, because we know that it's the angle that's subtended by this chord because the leg of this angle rests on this chord. That's what we mean by the angle is subtended by the chord, because its legs, the legs of this angle rests on our chord. And so that means that this angle and this angle are going to be the same. And that's what that theorem says. It says that if we have a case where we have the tangent line and a chord, and we have the angle that's between that, that angle is going to be equal to the angle subtended by the same chord in the alternate segment. Okay, so let's apply the same rule here. So if we notice carefully, we have same thing. We have the tangent, right? So there's a tangent DE, right? That's a tangent. And we also have, let me put this in green. We also have the chord, right? The chord. So we have the tangent, which is DE, and we have the chord right here. And we have an angle, this angle right here. This angle is the angle that is in between. This angle right here is the angle that's in between. Let's use the pen. This angle right here is the angle that's between the tangent and the chord, right? Now they're saying that the form, according to our theorem, they're saying that if we have an angle that's between the tangent and the chord, it's going to be equal to the angle subtended by the same chord in the alternate segment. So let's look at that angle, right? Let's look at that angle. So if we look carefully at that angle, we'll notice that we have this angle 37, right? And this angle 37 is the angle subtended by the same chord. How do we know? If we notice the legs of this angle, so this is one leg of the angle, this is another leg of the angle. Those two legs rest on the chord, right? That means that this angle is subtended by this chord, right? Because the legs of this angle rest on, you could say, the shoulders of this chord. And so that means that this angle 37 is going to be equal to this angle right here. So both of them are 37. And so that means that angle BCE is going to be equal to 37 because they are equal based on the alternate segment theorem. So this is 37 and this is 37. Okay, let's move on to the next question. Here it says we're going to figure out the angle BAC, angle BAC. So angle BAC, I'm sorry, angle DAC. So D, right, DA, right, DAC. So we're zeroing in or zooming in on this particular triangle because that's what they told us, DAC. Now we want to focus in particular. To angle A, right? That's the one in the middle. That's the angle we're trying to find, angle A. So that's the angle we're trying to find, this one right there, angle A. What is the measurement of this angle? The one thing we know is that this is 65 degrees, right? And based on another useful theorem, the theorem tells us, this theorem tells us that if we have an angle between the tangent and the radius, that angle is going to be 90 degrees. And if we look carefully, right, this line segment is the tangent, and this right here is the radius. How do we know that this is the radius? Well, we know it's the radius because let me highlight it. We know that this is the radius. This right here is the radius because this is the origin, and we have the line that moves from the origin to the circumference. That's definitely the radius. So the one that's in green is the radius, right? This one is the radius, and this is the tangent. So the angle formed between them is going to be 90 degrees, right? 90 degrees. So the angle between the radius in green and the tangent in blue is going to be 90 degrees. So that means that we know that this is 90 degrees and we know that this is 65 degrees. We only need to figure out this angle here. And to do that, what we have to do is we have to remember that angles in a triangle add up to 180 degrees. And so what we need to do is we need to subtract 180. So first we have to add. Let's do that. First we have to add 65 and 90, right? And then subtract that sum from 180 degrees. So we have 180 minus 55, and 180 minus 55 is definitely going to be 25 degrees. And so how do we get that? We added 65 and 90, right? Add those two, then subtract it from 180 and we get 25. So that means that DAC is 25 degrees because angles in a triangle add up to 180 degrees, and also because of using this theorem which tells us that the angle between the tangent and the radius is 90 degrees. Okay, let's move on to the next question. Here we have this next question, question number 12. I'm trying to figure where is question number 11. I move on from question number 12, question number 10 to number 12. So I'm going to pause it and then see what happened to question number 11 and then return. So give me one moment to pause it and then return back to see what happened to question 11. Okay, let's consider question number 11. This one is question number 11. And here we have a figure. We have, this one is 28 centimeters, right? And notice that we have this line, this horizontal line right here. This means that if we look carefully, here we have, this is 28 centimeters. Because we have this horizontal line right here, and we have this horizontal line right here, it's only one horizontal line. That's telling us that this particular length is the same length of this one. So they share length. So they are equal in length, right? So both of them are going to be 28 centimeters. So this is 28 centimeters, and because it's only have one horizontal line, that means that this is 28 centimeters, and this is also 28 centimeters. That's what that means. So they are equal in length. Now, if we have two sides, this is a quadrilateral. It is a four-sided figure. If we have this side is 28 centimeters and this side is 28 centimeters, then we're definitely looking at a square. They didn't tell us it's a square, but we know it's a square because if this side is 28 centimeters, then that means that this side is going to be 28 centimeters. And if this side is 28 centimeters, that means that this side is 28 centimeters. And so that means that all of the sides are equal, so we're definitely dealing with a square. So just bear that in mind. So altogether, the length of all of this, altogether, the entire length, right? The entire length is going to be 28 centimeters, right? So this one right there is 28 centimeters, okay? And then altogether, right, altogether, the length here is also going to be 28 centimeters altogether. So, okay, so we have a square. So 28, 28, 28, 28. All these lengths in totality add up. All these lengths in totality. So this length is 28, this length is 28, this length is 28, and this length is 28. So they are equal in measure, right? So all the sides are equal. So that's very important to note. But here they're asking us to find the perimeter of this shaded region. So we just want the perimeter of the part that is shaded, right? So let me outline the perimeter so that we can be sure we know what we're talking about. So this is the perimeter of the shaded region, this right here. So this side is accounted for, right? This right here is also a part of it, right? This right here is also a part, this curve region, this curve section. And this right here is also a part of it. And this right here is also part of it. So that's the perimeter of the curve section right there, the part that I highlighted in blue, okay? So if we want to find the perimeter, we have to add up all of the lengths, right? So let's do that. So the perimeter is going to be, first we have here 28. Why do I have 28? Because 28 is going to be this side, all right? That's 28. So we cover this side. So this side is 28 centimeters. That's covered, right? That's that length. And then we need to figure out, why do I have 28 here? Well, we have 28 because 28 covers this side. This side is also 28, okay? This side is also 28. Now, if you notice here, I have 28 divided by 2. Where did I get that from? Well, if you notice carefully, I'm taking into account this side, right? This same side right there. This same side right there. This one right there. Because they told us that this side, the double, we have a double. If you notice carefully, we have two double lines, right? And this one is a two double lines, which means that this side and this side are actually equal, right? So if the whole thing is 28 centimeters, and we know that this side and this side are equal, well, that means that each of them are 14, because 28 divided by 2 is 14. So that means that this one is 14, right? When we say 14, we're talking about just this particular length right there. And then this one is 14, right? Okay. So this side right there is 14. That little piece right there is 14. That's why I have 28 divided by 2, right? And then this side is also 14. How do I know that? Because it has already had a double line. Let me erase this portion so you can see the double line clearly. So if you look carefully, you notice that this is a double line right here, and this is a double line, which means that these two sides or these two lengths are going to be equal. If we know that the whole thing is 28, this one has to be 14 and this one has to be 14. And so what that means is, that means that this part is 14. Okay. And this part is 14 as well. Okay. So that's why I have 28 divided by 2. And so here we have, okay, so the 28 centimeters comes from the first 28. So let's let me highlight it using, yeah, let's use yellow. So the first 28 comes from this one. That's the first 28, right? That's this one. That's the first 28. The second 28 comes from this one. Okay, that's the second 28, right? And then we have 28 over 2, which is 14. That comes from this one, that 14, all right? And then the second 28 over 2, which is 14, that comes from this one, okay? And so the only part that we need is we need this curved portion. We need to figure like, what is the perimeter of this curved portion, right? And if you notice that this curved portion is basically, if we have a circle, so if we have a circle, right? So let's, let me use another color. So if we have a circle, right? If we have a circle and we were to divide the circle into 4 pieces, so that's half, and then this is another piece right now, that's quarter. This circle, right now, this same curved portion, right? The same curved portion is this curved portion right there, right? So this is the curved portion for a quarter of a circle, right? A quarter of a circle. So this right there, this piece, right? Let's just focus on the curved portion. But let's talk about this same part before we even talk about the curved portion at length. So this part right here, let me yeah, okay, good. It's working. So this part right here, right? This part right here. That's what we call a sector of the circle. A sector of the circle. So this right here is a sector circle, or a quarter of the circle, right? So this is a quarter of a circle. And we just want this curved part of the quarter of a circle. So we're basically going to take the circumference, which is the whole circle, and divide it by 4. And that's why we take the circumference of the circle, which is 2 pi r, and divide it by 4. The reason why we divide it by 4 is because we just want the quarter of the circle, right? So we just want this curved portion right there, right? So we divide it by 4 because the circumference would be the whole curve thing. But we just want this part right there, a quarter of it, right? So a quarter of it. So we divide it by 4, okay? And so that's why this 2 pi r divided by 4 is going to be what we have for the curved portion. This one right there, the curved portion, okay? And so that's what we have. So we have the circumference, which is the distance of the entire circle, right? And we have we just want the quarter of it though. We just want the curved part. The curved part, we just want a quarter of that. So that's why we divide it by 4, because we just want the quarter of the circle, this part right here, that curved portion. Okay? Hopefully that makes sense. And so let's erase and let's move on to the next part. So now we have everything. We have this whole thing set up. Now we just need to do computations, right? And so we're gonna say 28 plus 28. 28 divided by 2 is 14. 28 divided by 2 is 14. We have 2 pi r over 4. I wrote it as 2 over 4 times pi times r, which is the same thing. I just broke it apart. So we have the 2 over 4. I put that by itself. Multiplied by pi, I put that by itself. And I put that r by itself. I wrote it like this so the computations will be clear. And so we have 2 over 4 multiplied by pi times r. That's the same thing as 2 pi r over 4. Okay. Now, what are we going to do? We're going to, what is pi? They told us that pi is 22 over 7. Pi is not 3.14 in this question. So you have to use what they told us. They told us that it is 22 over 7. So we're going to put 22 over 7 right here. And then we have 14. Why did I put 14? Well, 14 is the radius, right? So the radius, which is this, is 14. Right? That's the radius. And then this right here is the radius again, that's 14. So the radius is 14. And so now we just have to do math, right? Computations. And so first we're going to add 28 plus 28 plus 14 plus 14. That's going to be 84. So all of this is taken away. So that's good. Now we just have to multiply 2 times 22 times 14. What is that? That's going to be 616. And then 4 times 7 times 1 is going to be 28. Now we have the divide. 616 divided by 28 is going to be 22. So we have 84 plus 22, and that's going to be 106. So the perimeter of the shaded portion, right? The perimeter of the shaded portion, right, is going to be 106 centimeters. I should have centimeters here. So let's put centimeters, right? Centimeters. Okay, great. Let's move on to question number 12. Now we can move on to question number 12. So here it says, find the size of the following angles. We need to find the size of angle A, B, and C. So let's first deal with angle A. If we notice carefully, this is angle A. And angle A, we highlight this. Angle A is inside of this triangle. So this is our triangle right here. And so angle A is right here. And if you notice carefully, right, we have these two horizontal lines on the sides of this angle, which means that this side and this side are equal in length, right? They're equal in measure. So that means that we're looking at an isosceles triangle. So that means that the sides, these two sides, are equal in length, which also means that these two angles are equal in length. So this angle, which is 25, is also going to be 25 on this side because they are not only equal in length, but we not only have two sides that are equal in length, because we know it's an isosceles triangle, the two angles are going to be equal in measure as well. So if this is 25, this is 25. Now we just need to figure out what A is. Angles in a triangle add up to 180 degrees. And so that means that we have to subtract our sum, which is 25 plus 25, from 180, which is going to be 180 minus 50, which is going to give us 130. So 130 is going to be the measure or the size of angle A. All right, and we got that because it's an isosceles triangle and the two angles are equal. Okay, let's move on to B. So for B, let's look carefully at what B is. Let me erase all ink. So for B, we have another triangle. So this is B. This is the triangle that B is in. And if we look carefully, each one of these have a double dash, which means that all of these are equal in measure. That means that we're dealing with an equilateral triangle. And if you're dealing with an equilateral triangle, that means that all three angles are equal. So this angle is equal to that angle, which is equal to that angle, and all of the sides are equal as well. So that means in order for us to figure out the size of B, we're just going to take 180 divided by 3 because there are three angles that must be shared equally. And so we have 180 degrees divided by 3, which is going to be 60, right? So we have 180 that must be shared equally among three angles. That's what I should say. And so 180 divided by 3 is 60. So each one of these angles is 60 degrees. And so B is 60 degrees. Let's move on to C. If we look at C, let me erase all ink. C is this angle, this one right now. And if you look carefully, we have, we basically have is angles around a point because, and here it says angles around a point add up to 360 degrees. So what we basically have is this angle along with this angle, along with that angle, right? So they are around a point, right? Angles around a point. If you could look at it as like a complete circle or complete turn. And so angles around a point add up to 360 degrees. So that means that this angle, which is C, this angle right there, plus A plus B, all of them should add up to 360 degrees. We already know what A is. A is 130. We already know what B is. B is 60. So we're going to have 360 minus 130 plus 60. And 360 minus 130 plus 60, well, 130 plus 60, that's 190. And 360 minus 190 is definitely 170. So C is equal to 170 degrees because angles around a point add up 360 degrees. Let's move on to part B. Here it says find the sides of the following angles. We want to figure out the size of angle X. All right, so if we look here, this is angle X. All right, this here is angle X. I want to figure out the size or the measure of angle X. And how are we going to do this? If you look carefully, right? Look carefully, let me use red. If we look carefully, we have a shape that we have here. This right here, right? This right here. Go down. This right here, go this way. Right, so what shape do we have? Look carefully. And this right here goes up. Okay. So what shape is this? Or what letter is this, right? This is Z, right? And so if we have a Z, we know that this is alternate angles. So this is 52, and this is also 52, right? So alternate angles are equal. So the way you can identify them is that if we have a Z shape, you have two parallel lines, right? And then we have a Z shape. So if this is 52, that means that this is also 52 because alternate angles are equal. And so they form a Z, just like how this diagram is showing. So 52 is our answer for angle X. And because alternate angles or alternate interior angles are equal. Okay, let's move on to the next question. So it says we want to figure out the length of Y or the size of Y. Well, they told us that Y is equal to 2x. The good part is that we already know what x is. X is 52. So if y is 2x or y is 2 times x, we just need to multiply x times 2. So 2 times x is going to be equal to 2 times 52. And 2 times 52 is definitely 104. So that means that y is equal to 104 degrees because y is 2 times x. X is 52. We multiply 2 times 52. That gives us 104. Now z. So y is, we know y is 104. Okay. Now z, how are we going to figure what z is? Well, z, well, we know that this is a quadrilateral. Here I have angles inside a quadrilateral add up to 360 degrees, and that's how we're going to get z, because if we know this right here is a four-sided figure, right? This right here, that's one side. This is two sides. This right here is three sides. And this right here is four sides. So it is a four-sided figure, and angles inside a quadrilateral add up to 360 degrees. We already know that this is 52. We already know that this is 118. We already know that this is 104. And this is 104. And so all we need to do is add these three angles and then subtract their sum from 360. So we have 360 minus 52 plus 118 plus 104. And so we have 360 minus 274. And 360 minus 274 is definitely 86. So z equals to 86 degrees. Okay, let's move on to the next question. Here we have number 13. This is a trigonometry question. It says the diagram shows the design plans of a sail. Calculate correct the nearest whole number, the length hg. Where's hg? Hg is this particular length right here. This is hg. And if we look at the triangle right there, this triangle right there, hg is actually the hypotenuse of this right angle triangle. And we know it's right angle because if this is 90 degrees, this side must also be 90 degrees as well because 90 plus 90 is 180. They are on a straight line, so they must add up to 180 degrees. So this is a right angle triangle. This side is the hypotenuse, all right? And we have a rule that can help us to figure out the size or the measurement of hg because there's something called Pythagoras theorem. And Pythagoras theorem is going to be able to help us to find the length of this side, hg. We already know what this side is, and we already know what this side is. This side is 64 feet. This side is 41 feet. And so we're going to call this one A. We're going to call this one B. And we're going to call this C. And so based on Pythagoras theorem, C squared equals to A squared plus B squared. What is A? Well, A is 64 feet. So we have 64 feet squared plus 41 squared. So we have 64 feet squared 64 squared, which is 4,096, and we have 41 squared, which is 1,680. If we add these two, it's going to be 5,777. And if we want to take the square root of both sides, if we want to find C, we have to take the square root of both sides. And so we take the square root of both sides and we cancel the square root with the square. That leaves us with C is equal to the square root of 5,770. Sorry, C is going to be equal to the square root of 5,777, which is 76.00657866. But they want it to the nearest whole number. And so we're going to underline 6, circle 0. And if we notice carefully, 0 is less than 5. So we do not round up, we just leave it. Just going to be 76. So that means that HG is 76 feet. Okay. So we got the length of HG. Let's move on to the next question. Here they want us to calculate the nearest whole number. The angle, this is the symbol for angle. The angle XGH. XGH. So we have X, right? G, and then H. So we want to zoom in on this triangle. The good part about this particular triangle is that we have all the sides, right? We have the lengths of all of the sides. We know that this is 64 feet, this is 76 feet, which we just calculated, and this is 41 feet. And we also know that it is a right triangle, so our trig ratios will be appropriate here. So G, right there, G is just going to be this angle right there. G is the one in the middle, so that's this angle right there. So let's label the sides of this thing, right? Let's label the sides. If you would label the sides, this is theta, that's the angle that we're trying to find. The angle across from theta, this angle across from theta is what we call the opposite sides. That's why I have O is opposite. The angle opposite the right angle is going to be the hypotenuse. That's going to be 76 feet. And the angle that's left, and the side that's left over is the adjacent side. So the side that's opposite the given angle is 64 feet. That's the opposite. The side that is opposite the right angle is the hypotenuse, which is 76. And the one that's left over is the adjacent side. And so which one of these we could use? Sine, cosine, or tangent? Well, we could use any one. We could use sine. So SOA, this is SOHCAHTOA. So S sine for sine. And if you're trying to find the sine, it's gonna if we're trying to find a formula for sine, it's going to be sine theta, which is going to be the opposite divided by the hypotenuse. Cosine is going to be the adjacent divided by the hypotenuse. And tangent is going to be the opposite divided by the adjacent. Now, for this one, we could use any one of these trig ratios. I'm going to choose to use tangent, which is the opposite divided by the adjacent. I want to use this because I don't want to use the hypotenuse, because the hypotenuse was a value that I found. And in general, you don't want to use the values that you find. You want to use the values that are given, because what if you are wrong, right? What if 76 is not the answer? Then, then we would end up getting a wrong answer for this one. So use the ones that they give you, unless you have to use, one of the sides that you find, then that's no problem. But if you have an option, don't use the one that you found. Use the ones that they gave you. So I want to use the opposite side and the adjacent side. So that means that I could use tangent, right? That tangent ratio. So what is the opposite? The opposite is going to be 64. What is the adjacent? The adjacent is 41. And so we have 64 divided by 41. We have tan theta equals to 64 divided by 41. In order to find theta, because that's what we're trying to find, we have to take the tan inverse of both sides. And so tan inverse of tan theta, and we have tan inverse. So we take the tan inverse of both sides so that we can cancel out. So this tan inverse cancel out with tan, and we just left with theta is equal to tan inverse 64 divided by 41. So the opposite of tan theta is tan inverse. And so that's why we took the tan inverse of both sides, because whatever you do to one side, you have to do to the other. And the reason why we're trying to use tan inverse is because we just want theta. We don't want tan. So we have to do tan inverse of both sides to get rid of that tan, so we just could have theta. So we have theta is equal to tan inverse of 64 divided by 41. Tan inverse of 64 divided by 41 is going to be equal to 57.35535987. Just put this inside of your calculator. And so that means that theta is going to be equal to 57 degrees because we want it to the nearest whole number. And if we underline 7, circle 0, circle 3, we notice that 3 is less than 5. So we can't round up. So we just have 57 as our answer. Correct to the nearest whole number. Okay, let's move on to the next question. So here it says we want the length EG. Now this is very important because here we want the entire length EG, right? We want the entire length EG, right? Now we know that XG is 41. Well, that's good. But we don't know what is EX, right? EX. So what we have to first find is what is EX. And once we find out what is EX, then we're going to add it to XG, which is the 41, to get the entire length of EG. Okay? So let's find out what EX is. If we're trying to find out what EX is, notice that EX is going to be just this particular side. This is EX, right? And if we could find out what is EX, then we can add it to XG to get EG, all right? So let's find out what is EX. Well, notice carefully that EX is a part of a bigger triangle. So this triangle right there, and this one. And so it is a right triangle. So the angle that is opposite the right triangle is the hypotenuse. The angle that is opposite the side that is opposite the right angle is the hypotenuse. The side that is opposite the angle is the opposite, and the rest, the other side is the adjacent. So let me repeat that. The side that is opposite the right angle is the hypotenuse. The side that is opposite the given angle is the opposite side, and the one that's left is the adjacent. Okay, so we have our sides are labeled. Here we are limited. So this is very important. We do not know what the adjacent side is, but that's the side that we're trying to find. So that means that we only could use cosine, or we only could use tangent. Why is that? Because we're trying to find the adjacent side. And so you have to use one of the ratios that have the adjacent side in it. Sine theta, it only can help you find the opposite or the hypotenuse. It can't help you find the adjacent. So we cannot use sine because we are not looking for the opposite. We're not looking for the hypotenuse. We're looking for the adjacent. So we either could use cosine or we could use tangent because both of them have a in it. Both of them have the adjacent side. Now, what have we been given? Well, we know what the opposite is, but we do not know what the hypotenuse is. So because we don't know what the hypotenuse is, we cannot use cosine, because in order for you to use cosine, you would need to know what the hypotenuse is. And in this case, we do not know what the hypotenuse is, right? What we do know is we do know what the opposite is. The opposite is 64 feet. And so we can use that because tangent says, okay, tangent has the opposite, it has the adjacent, it has the side that we have, it has the side that we are looking for. And so we are able to use tangent. So we can use tan again. So tan theta is going to be equal to opposite over adjacent. Notice that theta is the given angle. That's 48 degrees. That's this one right there. And then the opposite is going to be 64 feet, which we notice from the diagram. The adjacent is going to be x because that's the unknown. We don't know what that is. Now I'm going to put tan 48 over 1, and we're going to cross multiply because we're trying to find x. So x times tan 48 is going to be x tan 48. 1 times 64 is 64. Here I'm going to divide both sides by tan 48 because I'm trying to find out what is x. So I don't want nothing on that left-hand side. I'm trying to isolate x. So these two cancel. So we cancel both sides by tan 48. And so we get that x is equal to 64 divided by tan 48. So x equals to 64 divided by tan 48. You can put this inside of your calculator. 64 divided by tan 48, which is going to be 57.6258 5884. All right, now we want it correct to the nearest whole number. We know that 6, right? 6 is greater than 5, so we're going to add 1 to 7. And so we end up with, oh, I'm sorry. I went ahead of myself. We only figured out x is just EX, right? When we figured it out, that's just EX. That's just this value, right? We just figured out what EX is. That's all we did. Now we need to add EX to 41. My apologies. We have to add EX to 41. We're not gonna round because this is not our final answer. So we still have some adding to do. So we're gonna add EX, which we just found. That's EX, right? That's EX is 57.6258584. That's EX. And we're gonna add that, which is the adjacent side. We're gonna add that to XG. And so let's do that. So we have 57.6258584 plus 41. And we're going to add them together and we get 98.625858884. Now we have EG, right? Now we have EG. Now we could round to the nearest whole number and we have 98.6. 6 is greater than 5, so we're going to add 1 to 8, which is going to give us 99 feet. So EG, the entire length EG, which is the sum of EX and XG, is going to be equal to 99 feet. Okay, let's move on to the next question. Here we have number 14. It says, in a dart game, Jordan can hit targets that are either a circle or a star. Let the number of times he hit the circle be A and the number of times he hits the star be B. Jordan hits a total of 24 targets. Write an equation for this information in terms of A and B. So the number of times he hits the circle is going to be A. So we're going to put A plus B, right? And that's going to give us 24. So the number of times he hits the circle and the number of times he hits the star is going to be A plus B, which is going to be equal to 24. That is the first equation. Now, hitting a circle scores 8 points and hitting a star scores 10 points. Jordan scores a total of 218 points. Write an equation for the total score of A and B. So remember, 8 points for hitting a circle. So we're going to have 8A because the circle is A. And then 10 points for scoring a star. Sorry, and then 10 points for each star, right? 10 points for hitting a star, so it's going to be 10 times B. So 8 times A because it's 8 points for every circle that you hit. And then 10 times B because it's 10 points for every star that you hit. So we have 8A plus 10B is going to be equal to 218. And so that's the second equation. So the first equation is A plus B equals to 24. The second equation is 8A plus 10B is equal to 218. So now we have our two equations. Next, they tell us solve the simultaneous equation. This is part C of our question. Solve the simultaneous equation to find out how many times each target was hit. So here we have the simultaneous equation. We're going to call this first one equation 1. We're going to call the second one equation 2. Our first step, we're going to make A the subject of equation 1. So we're going to use substitution to figure this out. So make A the subject of equation 1. What does that mean? We're going to take A plus B equals to 24. We're going to take that and we're going to make A the subject. So that means we're going to send B over, right? Send B over. And so it's going to be A is going to be equal to 24 minus B. So we send the B over the equal sign. So A is going to be equal to 24 minus B. Okay? That's what A is. A is equal to 24 minus B. And that's how we make A the subject. So A is now the subject of this equation just by sending the B over. The next step, we call this equation 3. So this is equation 1, this is equation 3, and this is equation 1, this is equation 2, and this is equation 3. Now the next step, step number 2, substitute equation 3 into equation 2 and solve for B. Substitute equation 3 in equation 2 or into equation 2 and solve for B. So we're going to take equation 3, which is A is equal to 24 minus B, and we're going to plug it into equation 2. What is equation 2? Equation 2 says 8A plus 10B is equal to 218. But we already know that A is 24 minus B. So let's put that inside the equation. So A is 24 minus B, that's A, right? So in place, instead of writing A, we write 24 minus B because that's what A is. Now we're gonna distribute 8 times 24 multiplied by 8 times negative B. 8 times 24 is 192, and 8 times B is 8 times negative B is negative 8B, plus 10B is equal to 218. Next up, what we're gonna do? Well, we're going to add negative 8B plus 10B. And so negative 8B plus 10B is going to be equal to 2B. And so we have 192 plus 2B is equal to 218. Now, what are we going to do? We're going to send the 192 over the equal sign. So we have 2B is going to be equal to 218 minus 192. Now, we're going to subtract. 218 minus 192 is going to be equal to 26. So now we have 2B is equal to 26. We have to divide both sides by 2. Cancel this 2. I should have put the cancellation. We cancel this 2 with this 2. And so we're left with B is equal to 13. Now we know what B is. So we know what one value is. We know the value of B. Now we're going to use the value of B to figure out the value of A. So the next step says substitute B is equal to 13, what we just figured out, into equation 3 and solve for A. What is equation 3? Equation 3 is A is equal to 24 minus B. We're going to take that B, we're going to put it into, we're going to take this B and we're going to change it into 13 because B is equal to 13. And so A is going to be equal to 24 minus 13. Remember, B is 13. And so A is equal to 24 minus 13, which is going to be 11. So that means our answer is that A is 11 and B is 13. Okay. So let's move on to the next question. Here we have number 15. It says, in a survey, a group of 1,440 tourists were asked to name their favorite Bayman dish. The responses are shown in the pie chart below. We have 20% who like minced lobster, 15% who love steamed grouper, 108 degrees for conch fritters. We don't have any information for crab and rice, and 90 degrees represents conch salad. They want us to find the angle representing minced lobster, the angle representing minced lobster. Here we know the percentage, so we're going to say the 20% of 360. Why 360? Because angles in a circle, angles around a point add up to 360 degrees, right? So 20% of 360, because it's 360 degrees, 20% is going to be represented as 20 over 100. Of means multiply, so we have 20 over 100 multiplied by 360 over 1. We multiply 20 by 360, that gives us 7,200. We multiply 100 times 1, that gives us 100. And then we divide. 7,200 divided by 100 is 72 degrees. So the angle representing minced lobster is 72 degrees. Let's move on to the next question. It says, find the percentage of tourists that choose conch fritters. Now, here, we don't know the percentage of tourists, but we know the degrees, right? We know the degrees is 90 degrees. And so it's going to be, in order for us to find the percentage of tourists that choose conch fritters, we're going to take, I am so sorry, says conch salad. We know that the percentage of tourists that, we're trying to find the percentage of tourists that choose conch fritters. Here, 90 degrees is for conch salad, my apologies. So if we want to try to find the percentage of tourists that choose conch fritters, we have to go to this one. This is 108 degrees, right? So we know that 108 degrees is for conch fritters. If we try to find the percentage of tourists for conch fritters, we're going to take 108 degrees divided by 360. Why 360? Because angles in a circle around a point, right, add up to 360 degrees. So all of these angles right there inside the circle are going to add up to 360 degrees. So 108 is a fraction of 108 is one of the angles inside of this circle. So we say 108 divided by 360. And so that's 108 divided by 360. That is conch fritters represented as a fraction. But we want it to represent as a percentage. So we're just going to multiply it by 100. And so 108 multiplied by 100 is definitely going to be 10,800. 360 multiplied by 1 is 360. And if we divide 10,800 by 360, that's going to be 30. So the percentage of tourists that choose Kong fritters is definitely going to be 30%. Let's move on to the next question. Here we want to figure out the number of tourists that picked crab and rice. The number of tourists that picked crab and rice. Here, what we're going to do is we're first going to figure out what is the percentage of tourists that choose Kong salad. Why is that important? Well, it's important because notice carefully that we have the percentage for minced lobster. We have the percentage for steamed grouper. We just figured out the percentage for Kong fritters, which was 30%, right? And so if we could figure out the percentage of Kong salad, that would be helpful in figuring out the number of tourists that we have for crab and rice. So we're going to change all of them to percentage, right? We already have this one as a percentage. We already have this one as a percentage. We already have this one as a percentage. Now we need Kong salad as a percentage. Now, what do we have for Kong salad? Well, Kong salad is 90 degrees. Well, we're going to say 90 degrees over 360. That's the fraction of Kong salad we have. We multiply it by 100 to get the percentage. 90 times 100 is going to be 9,000. So we have 9,000 divided by 360, which is going to be 25. So Kong salad accounts for 25% of this particular pie chart. So we have everything in percentage. We have Kong salad as percentage, minced lobster as a percentage, steamed grouper as a percentage, and Kong fritters as a percentage. Now we need to figure out the percentage of crab and rice. So if we're trying to find the percentage of tourists that picked crab and rice, we're gonna say 100 minus 20% from the minced lobster, 15% from the steamed grouper, 30% from the Kong fritters, and 25% from the Kong salad. If we subtract them, we get 100 minus 100% minus 90. The reason why we subtracted from 100 is because all of these together, as in terms of a percentage, should add up to 100%, right? But in terms of an angle, they add up to 360 degrees. But in terms of a percentage, they have to add up to 100%. So in order to figure out the percentage of tourists for crab and rice, we have to take 100% minus 90%, which is going to give us 10%. So now we know the percentage of tourists for crab and rice, but we don't want a percentage of tourists. We want the number of tourists. So you're going to say, okay, 10% of the total number. What is the total number? 1,440. It's going to be 10% of, which is multiplied, 10% multiplied by 1,440. So it's going to be 10 over 100 multiplied by 1,440 over 1. We say 10 times 1,440. That's going to give us 14,400 divided by 100. And so that's going to give us 144. So the number of tourists that picked crab and rice is going to be 144 tourists. Let's move on to this next question, question 16. We just finished question 15, so we move on to question 16. Here we have a graphing question. So we have the height, right? So we have this table, this table that we have, for this table, we have the height, and we have the cross-sectional area. It says the table shows the relationship between the height of a box and its cross-sectional area. So when the height is 1, the cross-sectional area is 180. When the height is 1.5, the cross-sectional area is 120. When the height is 3, the cross-sectional area is 60. When the height is 5, the cross-sectional area is 36. When the height is 6, the cross-sectional area is 30. When the height is 9, the cross-sectional area is 20. When the height is 12, the cross-sectional area is 15. And when the height is 15, the cross-sectional area is 12. So they're saying using a horizontal axis that's left to right, that's your x-axis, right? Of 1 centimeter to 1 unit for the height, and a vertical scale of 1 centimeter to 10 units. This is huge. That means that every 1 centimeter that you have is going to be 10 units. So you're basically going to be counting in tens. For the cross-sectional area, plot the data points from the table and join them with a smooth curve. So here they were nice. They told us exactly what it is. It's a smooth curve, not a line. So let's first do this, right? Let's represent this. So we have the point. Let's plot the points. So we have the point 1 and we have the point 1 and 180. So here I'm going to show you the finished product, but let's do it step by step. We have the point 1 and 180. So that's going to be where that point is right now. And then what else we have? We have the point, what else they say? 1.5 and 120. Before I even get to the points, what I should show you is how I like did the diagram first. So remember what they said? They said that 1 centimeter to 1 unit, right? That's important. So that means that on the x-axis, we're counting in ones. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We're counting in ones. And this is the height, right? So I have that height labeled. And then for the y-axis, they told us that, hey, listen, you must count 1 centimeter to 10 units. That means that we count in tens. So this is gonna be 0, then it's gonna be 10, it's gonna be 20, it's gonna be 30, it's gonna be 40, it's gonna be 50, 60, 70, 80, and so on, all the way up to 190. So the y-axis you're counting in tens, the x-axis you're counting in ones, all right? Now let's plot the points. So the first point is 1 and 180. This right here, x, these are your x values. These are your y values, right? So that means that the first point, we have 1 and 180. So that's going to be 1, right, and 180, right? So that's where that point lies. The next one is 1.5 and 120. Now, let me erase this. 1.5 and 120, erase this. Erase all ink. So if we look carefully, we want 1.5, right? So 1.5 is going to be, this is 1, this is 1.2, this is 1.4, 1.6, 1.8, this is 2. So in between 1.4 and 1.6, that's going to be 1.5 right there. All right, so we want 1.5. Let me use this. We want 1.5 and 120. That's going to be right there. Again, in between 1.2, 1.6 is 1.5. And it's going to be 120, right? So that's that point there. The next point that we have, what's the next point that we have for this one? The next point that we have, if we look carefully, the next point is 3 and 60. That one is easy because 3 and then 60. Okay, so we have 3, right? And then 60 on the y. So that's your point right there. And the next point is going to be, the next point is 5 and then 36. So 5 is right here. That's 5. But we want 36. This one right here is 30, right? This is 30, but we want 36. So let me move over. So we want 36. So if this right here is 30, and this is 40, this is going to be 30, 32, 34, 36, 38, and 40. So this right here, right at this point, this is where 36 is, right? So we have 5 and 36. That's how we get that. Let's move on. Then now we want 9 and 20. 9 and 20. So 9 and 20, let's go to 9 and 20. This right here is 9, right? And we want 9 and 20. Where's 20? I think do I have this on the right line? Let's see if we have it on the right line. This is 9 and 20. Where's 20? So I hope I have it right. Okay, yeah, it is right. 20. If we go across, it's 20. All right, so let me scooch it over. So 9 and 20, that's at this point right there. So 9 and 20. So 20, if we go over, that's 20. So 9 and 20, that's where we have it right there. So that's pretty good. The next one is going to be, the next one is we have 12 and 15. 12 and 15. So 12 and 15, that's going to be 12 and 15. So let's zoom in. 15. Well, what do we know? 15. This right here is 10. This line here is 10. If we go over, we can see that this line is 10, right? So this is 10. So all the way across here, that's 10, right? So this line is 10. Now we have 10, then we have 12, then we have 14, then we have 16, then we have 18, then we have 20. What they want is they want 15. So 15 is going to be between sorry, this is 10, this is 12, this is 14, and this is 16. So 15 is going to be between 14 and 16. It's going to be in the middle there. So you have 12 and 15. Okay. And then the last one we have is 15 and 12. 15 and 12. Okay, what is 15 and 12? 15 and 12 is going to be this one. So this is 15 and 12. Remember, this line is 10, and this is 12 right there. So 15 and 12 is going to be right there. Okay, 15 and 12. And so that's how we plot it. And then all we need to do is draw a smooth curve. So let me erase all ink. So you're going to take your pencil and draw a smooth curve to connect all of those points. Right? You draw a smooth curve to connect all of those points together. All right, it's not a line, it's a curve. All right, and so you gotta be careful in how you make sure you get all of the points, and you're gonna get a smooth curve like so. All right, so it has to touch all of the points. Okay, and so there we have it, our curve. Okay. Okay, so now we have to actually answer questions based on this. So it says use your graph to estimate the cross-sectional area when the height is 4 units. So they're saying, what is the cross-sectional area? What is your y value when your height is 4? All right. And right there, we can see it. If the height is 4, right? If the height is 4, right? If we go here, if we go up, if the height is 4, then the y value is 45. Okay, let me erase all link. So if the height is 4, the y value is going to be 45. And now we know it's 45 if we were to zoom in carefully. This is 40. Let me erase those so that could be distracting. Erase that. Let's go over. This is 40. This is 42. This is 44. This is 46. So in between 42 and 46, it's 45. So if the height is 4, if the height is 4, then the cross-sectional area is 45. And so 45 is the answer I got. Let's move on to the next one. Let's go. Okay. Next, they say they want the height when the cross-sectional area is 90. So here they gave us the cross-sectional area, and now they say, well, find the height. So here they gave you the y, and they want you to find the x. And so let's go here. We have, if the height is 90, what is the, sorry, if the cross-sectional area is 90, what is the height? If we go down, and you go down enough, this is about 2.8, 2.08, okay? It's about 2.08. How I got that? This is 2, this is 2.2, 2.4, 2.6, 2.83. So this line right there, it's not exactly 2.1, but it's not too far from 2.1. So I'm saying it's about 2.08. All right. So that's what I got. So the answer for this one is it's gonna be when the height is when the cross-sectional area is 90, the height is gonna be about 2.08. Okay. Okay, let's move on to the next one. This one we have to describe fully the single transformation that maps shape A onto shape B. Okay, so here we have shape A. This is shape A right now. Okay, very interesting figure. The shape A, this is shape A. And what we have here is we have something happened, this thing transformed, and now we have shape B, right? So the question is, what happened? If you look at it, it's clearly a reflection. It's a flip, right? So if you look at it, it's a reflection. So we can, just by observing it, we can see it's a reflection. But we have to give a, let's say, describe fully. So we have to, be a little bit more specific. And so if you look carefully, this right here is the line of reflection. That's the line y is equal to -1. And how do we know that? If you look carefully, right? Let's look at this point. We have to move 1, 2, right? 2 spaces. And if we go 1, 2 spaces, we get at this point, right? And then if we go 1, 2, that's 2 spaces, right? If we go 1 and 2, that's another 2 spaces. So they are equally spaced apart, right? So this line, right, spaces them, gives them equal distance. So this, what I mean by equal distance, I mean this one is 2, this one is another 2, this one is 2, this one is another 2. So it's what we call the line of reflection, right? And then this one, if we do this point, this is 1, 2, 3, 4. That's 4 spaces apart from this line. So this one obviously have to be 4 spaces. So it's going to be 1, 2, 3, 4. So that means y is equal to, the line y is equal to -1 has to be the line of reflection because it makes them equal spaces apart, right? So what we have here, if we want to write this fully, we're going to say that this is a reflection in the line y is equal to -1, okay? And y is equal to -1 is a horizontal line that passes through -1, all right? Let's move on to the next question. Here we have, we want a transformation that maps on shape A to shape C, okay? So here we have shape A, now we have shape C, and if you look at it, what does it look like, right? It looked like we turned the image, right? So it's just by looking at it, you can see it can't be a reflection. I mean, even though it sort of looked like a reflection, like it oriented the same way, but we actually like turned this thing. Like we actually turned it. Okay, so this is a rotation, and it's a rotation of 180 degrees counterclockwise. So it could be counterclockwise or clockwise. Same thing, because when we're dealing with 180 degrees, it doesn't matter which direction we go, it's still gonna be the same position. So we could turn it this way, right? Or we could turn it the other way and still end up the same thing. So like, okay, how do we know it's 180 degrees? And it says 180 degrees counterclockwise about the origin. That's what I'm saying it is. Now, how can I verify that that's the case? Well, we can verify by looking at the coordinates. So if we look carefully, right, we call this image the pre-image. So the image before we apply a transformation is what we call the pre-image. And if you look at this point, so let's look at this point right there. That's the point. Let me use a different color. So erase. So let me use a different color. So if we look at this point, let's use red. If we look at this point right there, that's the point 1, 1. All right. That's the image of, sorry, that's the point 1, 1. Now, if you look at the image, which is C, well, if we look here, this is the point -1, -1. So we see a transformation was applied to this one, right? Now let's go to another point. We have the point 3, 1. Let's look at this point. This point right here is 3, 1. And if we look here, if we look at this one, this point is -3, -1. So this point was rotated here as well. And then if we look at this point, right, this one, there's a point 2, 3. And if we look here, 2, 3 is rotated to -2 and -3. So basically what happened is that all of their coordinates was negated. And whenever that happens, that is definitely a rotation of 180 degrees clockwise or counterclockwise. This is the formula. So if you have a rotation of 180 degrees clockwise or counterclockwise about the origin, it's going to take your image of your pre-image coordinates and negate them. So that's how we know we're definitely dealing with a rotation of 180 degrees about the origin, because whenever we have a rotation of 180 degrees, it takes our pre-image, right, the coordinates of our pre-image, and rotates and negates those coordinates. So we have -x, -y. All right, so just bear that in mind, right? So that's how we know for sure that our answer is right, because if we look at each coordinate, we see that it's definitely rotated, and each one of them is negated, right? Each coordinate is negated, and so it's exactly what the formula says. If we have a rotation of 180 degrees clockwise or counterclockwise or anticlockwise, it's going to take our pre-image coordinates and negate them. Okay, so let's move on to the next one. This one says, describe fully the single transformation that maps shape A onto shape D. So we have shape A and we have shape D. Just by looking at it, it looks like a translation. All right, so it's a translation. Now it's a translation, but using which vector? So let's look at this particular point. If you look at this particular point, we moved how many spaces? 1, 2, 3, 4, and 5. So we move 5 places to the left. How many spaces up did we move? We move 1, 2. Okay, so we move 5 places to the right, to the left, and 2 places up. So that means that we have a translation using the vector -5 because it's 5 places to the left, so it's going to be -5, and then 2. So because it's 2 places above, it's going to be 1, 2. So we have a translation using the vector -5, 2. That's the transformation. Now, how do we know we're right? We know we're right because if we take the point, let's do it point by point. So if we take the point, erase all. If we take the point 1, 1, and we add it to -5, 2, we get 1 plus -5, which is going to be -4, and then 1 plus 2, which is going to be 3. So what do we have then? Well, we have this point, which is 1, 1. And if we look here, it says -4, 3. If we look here, we have -4, 3. So that was translated as well. We moved it over 5 times to the left, and we gone twice above. Let's take another point. We have the point 3, 1, right? The point 3, 1. And we adding it to -5, 2. And when we do that, 3 plus -5 is -2, and 1 plus 2 is 3, which means that we have the point -2, 3, right? Which means that we translated this vector, right, 5 times to the left, right, and 2 times above, right? And so that's another indication that we're dealing with the right vector. Now let's use this last coordinate right there, this one. And we have the point 2, 3, and we're going to add it to -5, 2. And if we do that, we have 2 plus -5, which is 2 plus -5 is 2 plus -5. What is 2 plus -5? That's going to be -3. And then 3 plus 2 is 5. So it's going to be, we're going to move this over 1, 2, 3, 4, 5, and then up to 1, 2. That's going to be exactly the coordinates -3, 5. And so this is definitely a translation using the vector -5, 2. Okay, let's move on to the next question. It says, describe fully the single transformation that maps shape B onto shape E, right? Let's look at the coordinates of B, right? If we look carefully, I have here, I already gave the answer away. I have here that it's an enlargement by scale factor 2, with the center of enlargement being the origin. Why would I say that? Well, clearly these, if we look at B and E, it's getting bigger, right? That's clear. It's a resizing. So every time we're dealing with resizing, that's a dilation, right? Or enlargement. So it's definitely enlargement. It's definitely getting bigger. But how big? How much bigger? And that's what we have to like quantify. So if we have the point, let's look at each point. So if we have the point 1, -3, let's look at this point, 1, -3. And so if we have the point 1, -3, this point right there, 1, -3. What happens when we multiply it by 2? Let's see, if we multiply 1 by 2, we get 2. If we multiply -3 by 2, we get -6. And so we have the coordinates 2, -6. What is 2, -6? 2, -6, that's this point right there. And so it is a enlargement by scale factor 2. Because if we took this point and we multiply it by 2, we get 2, -6, which is exactly the point on E. Now let's take another coordinate. So -3, sorry, 3, -3, 3, -3, that's this. 3, -3, 3, -3. So we have 3, -3. So what we have to do is we have to multiply by 2, and we get 6, -6. And if we look at this one, 6, -6, that's exactly the coordinates on this one. All right, so it's clearly a enlargement by scale factor 2. The last one, this coordinate, we have 2, -5. And so when we multiplied it by 2, we have 2 times 2, which is going to be 4. And then -5 times 2, which is going to be -10. So we have this one right there, 4 and -10. And so what that means is that we're dealing with an enlargement. But how do we know what is the center of enlargement? And so in order to figure out the center of enlargement, what we do We just figure where all those points intersect. So we draw a line here. So these two are going the same direction and they meet here. Okay. And then these two are coming together and they meet here as well. Okay. And then these two are coming there and they meet here. So this is definitely the center of enlargement, which is the origin, because all of these lines meet at this particular point, which is the origin. And so we have it right. An enlargement by scale factor 2, with the center of enlargement being the origin of the point 0, 0. Okay, let's move on to the last question. It says, Jamie purchases a laptop which costs $1,200. Jamie gets a loan for the full price of the laptop at a simple interest rate of 3% per year. She pays back the loan in equal monthly payments over 18 months. Calculate her monthly payments correct to the nearest cent. So here we're dealing with simple interest, right? So let's look at the simple interest formula. It says principal times rate times time all over 100. Here, what is the principal? Principal is the amount borrowed. So she's buying this laptop for $1,200, but she's getting a loan to get this laptop. So principal is the amount borrowed, and she borrowed the full price of the laptop. So it's going to be 1,200. The rate is going to be 3%, right? So that's R. And the time is 18 months, but we always do time in years. So we're going to divide 18 by 12 because there are 12 months in a year. So we get 18 divided by 12, which is going to be 1.5 years, 1.5 years, because 18 is 12 plus 6. 12 months is a year. 6 months is half of a year. So 1 year plus 1 year plus 0.5 of a year. Add them together, we get 1.5 years. And so we have everything we need. We have the principal, which is 1,200. We have the rate, which is 3. We have the time, which is 1.5. Let's put it into a formula. 1,200 multiplied by 3, multiplied by 1.5, and divided by 100. So we have to multiply them. So we have simple interest is going to be equal to 5,400 because 1,200 times 3 times 1.5 is going to be 5,400. Divided by 100, we're going to get 54. So 54 is our simple interest. But that's just the interest. How much does she have to pay back is the question. So the total amount owed that she have to pay back is going to be the principal, the amount that she borrowed, plus the interest that we calculated, which is going to be 1,200 plus 54. Why 54? That's the interest that we calculated. Why 1,200? Because that's the principal. Now, let us do the amount owed. So the total amount owed is going to be $1,254. That's how much she owed in total. Now, she have to pay every month. And so what is her monthly payments? So she have to pay $1,254 over the course of 18 months. And so we're going to take 1,254, we're going to divide it by 18, and that's going to give us 69.666667. But we want it to the nearest cent. So it's going to be, we're going to take this 6. We know 6 is greater than 5. So we're going to round up. So it's going to be 69.67. All right. And that's going to be our monthly payments. And if she pays that every month, she'll definitely pay this amount over the span of 18 months. Okay. That brings us to the end of this video. Thank you for watching, and I'll see you in the next video.